reasonably difficult separation of variables problem. And if you look at problem example 1 here, we have dy dx is equal to x times e to the x plus y. What's a good first step for that? I would definitely do that. You have dy dx is equal to x times e to the x, and then what do you do with this plus y? Times what? E to the y. Now you can separate those variables, put anything with y's on this side, dy, and 1 over e to the y, and anything with x's on this side. So when we integrate these, no problem on the left. This is just going to be e to the negative y. So what's the antiderivative of e to the negative y dy? Negative e to the negative y. So that's no problem. How are you going to take that antiderivative? X e to the x. Thank you. Integration by parts. So x times e to the x dx. This is a typical way that IB would combine a bunch of topics in one problem. You wouldn't see one this nasty on a BC test. Probably not. So you'd have a u dv. So u is going to be x. Use your Lie 8 to figure this out. Antiderivative of e to the x is e to the x. Derivative of x is dx. And that's your du and v. X, crazy x, marks the spot. Like that. So then you're going to get, this is going to be x e to the x plus antiderivative, actually minus antiderivative of e to the x dx. And what's the antiderivative of e to the x dx? Minus e to the x. So there you go. X e to the x minus e to the x plus c. And I would make this suggestion is use this one to find your c before you solve for y. Before you solve for y. So we said x was 0 and y was natural log of 3. So x equals 0. Y is the natural log of 3, so here goes. Minus e to the negative natural log of 3 equals 0 times e to the 0 minus e to the 0 plus c. Well, this is easy. It's just 0 times anything is 0. E to the 0 is 1, so it'll be negative 1 plus c on this side. Now, if I have a negative 1 here, I pull that up here. This is the natural, e to the natural log of 3 to the negative 1, or 1/3. What's e to the log base e of 1/3? 1/3. So if I add 1, what's c equal to? 2/3. Who got c equal to 2/3? Nice. 2, 3, good. About 1/3 of you. Next, once you have that, now go into the original equation here, the minus e to the minus y equal x e to the x minus e to the x plus 2/3. We're going to solve for e to the y first. So I'm going to get e to the negative y equal negative x e to the x plus e to the x minus 2/3. I just multiplied everything by a negative, and then the last thing that you could do, if you solve for y, is just go the natural log of both sides. So that's going to be negative y natural log negative x e to the x plus e to the x minus 2/3. And then what do? Divide by negative 1. This is like negative 1 times this, so could you see why I'd get natural log of 1 over e to the x minus x e to the x minus 2/3, yeah. This is the true equation for y equals. Very well deserved when we get to that point. And if you look at my answer up here, I solved for e to the x, or e to the y, but it's the same thing. Okay? So, but this is solved for y. Next, we're going to do the Euler's method. So I'm going to erase a few things here. And now we're going to do Euler's method. We're going to use the equation that's given here. Dy dx is going to be x times e to the x plus y. And we're going to use the formula y of n plus 1. Please write this down. Y of n plus h times the f of x of n, y of n. That's the formula for it. What we're going to do is we're going to start at x0 equal to 0, and then the y0 is going to be what? What's y0 equal to? Starting point 1, yep. Then after that, you're going to go h is equal to 0.2. That's my step size, h. Personally, when I'm doing Euler's method, I like to start with the formula y of 1 equals y0 h times x0 e to the x0 plus y0. That's the way I like to start it out. You do not have to write that out every time. It really helps me organize myself. So y1 is going to be y0, which is 1. H is 0.2. x0 is 0. E to the 0 plus 1. But anything times 0 is 0, so y1 is just, in this case, going to be equal to 1. This is y1. We're going to go all the way to x is equal to 0.6. So we're going to keep going here. Now I'm going to draw a line under this one, and now I'm going to go x1, y1, h equal to 0.2. My formula is y2 is equal to y1, h times x1 e to the x1 plus y1. So you go ahead and see if you can do that one, and then do the next one. Look at that, I still have lines from before. Then do the next one, and we'll see here how far you have to go. So x1 is 0 plus 0.2 or 0.2. y1 is my last y1 here. And we're not going to get a nice number this time. 1 plus 0.2 times 0.2 e to the 0.2 plus 1. And what did you get for a 5-place decimal? 1 point. Let's go 3 more decimals. 1.10. Yep, you're right. That's what we got last hour. So then for the next one, when we go 0.4, 0.2 goes to 0.4, 0.4 goes to what? 0.6, and then you're done, right? So then y2 is going to, let's see, yeah, this should get 2. 1.13280, h is still 0.2. So y2 plus h times x2 e to the x2 plus y2. So y3 is equal to 1.13280 plus 0.2. 0.4 e to the 0.4 plus 1.13280. And could you tell me what you have for y3? 1.5? 0329. So there's 5 decimals. And this is my estimate using Euler's method. It is not perfect because of the fact that it's parallel but not on the function. So what you might do is you might put 0.6 into my answer that we had from this part. Okay, this answer here, put that in for x to get your y, and then at the bottom here, compare it to this and get the error. Some of your problems have error. So that's how you do Euler's method for that estimating points, x of 0.6. You're going to go to y3, stop 1 before, 0.4 before 0.6, and that'll be your answer for estimating y of 0.6. Good.